So section 16.1 is synthetic division and the remainder theorem. And if you're dividing a polynomial by a linear function, there's a shortcut way of doing the polynomial division, synthetic division. And I just want to keep reminding you about these four equivalent statements, that if you know any one of them, you know all of them. So keep reminding yourself that if I tell you that x minus 3 is a factor or divides evenly, then you know 3 is a 0. And that means you know f of 3 is 0. So keep reviewing those four equivalent statements. That will really come in handy. And then let me also remind you that the dividend is the polynomial you're dividing into. So our example is going to be negative 4x cubed plus 5x squared minus 3x plus 8. And then the divisor is what are you dividing by? Then the quotient is going to be our result, and then there's a remainder. And you can always check your polynomial division, so please do that. And synthetic division's a little tricky because if you're dividing by x plus 3, then the 0 is negative 3. And so negative 3, the 0, is what goes in the pocket for the synthetic division. Okay, then in the same row as the negative 3, you put the coefficients of the polynomial, and you don't write the x part or the pluses or minus. They're included in the coefficients. So negative 4 represents the x cubed term, 5 represents the x squared term, negative 3 represents the x term, and 8 the constant. So then leave room for another row and then put a horizontal line. So the first coefficient always just drops down. So we get negative 4 as the coefficient we need for our quotient. Then negative 3 times negative 4 is 12. So we put the 12 under the 5 and then add vertically and get 17. So then we're going to do negative 3 times 17 and get negative 51 and add vertically and get negative 54. So then I'm going to do negative 3 times negative 54, and that's going to give me 162. And then I add vertically and get 170. So the last number is your remainder. So our remainder is 170. Then the other numbers represent your quotient. And just as we suppressed or didn't write the x parts of the terms, this is your quotient where the last number is the constant, the 17 is the x term, and the negative 4 is the x squared term. So your quotient is going to be negative 4x squared plus 17x minus 54. And let's check our result because we should get our dividend if we multiply our quotient times our divisor and add our remainder. So let's go ahead and make our box and have negative 4x squared and 17x and negative 54 and x plus 3. So I'll have negative 4x cubed, 17x squared minus 54x, negative 12x squared, 51x, and negative 162. So I'm going to write it above just because I have more space here. So I'll have negative 4x cubed plus 5x squared minus 3x minus 162. And then I add my remainder of 170 and check and make sure that that indeed matches my dividend. So then I know for sure I have the quotient correct and the remainder correct because I can check my answer. So some fine points, one of them is you have to put placeholder zeros for any degree term that's missing. So if I'm dividing by x minus 2, positive 2, or the 0 is what goes in the pocket. I'll have a 1 for the coefficient of x to the 4th, a 0 for the coefficient of x cubed, a 1 for the x squared, a 0 for the x, and a 2 for the constant. So the 1 just comes right down. Then I have 2 times 1 goes in the next column and add. So I get 2. Then 2 times 2 goes in the next column and add. So that gives me 5. Then 2 times 5 goes in the next column and add. So that's 10. Then 2 times the 10 goes in the next column and add. So our remainder is 22. And these other 4 numbers represent our quotient. So we have the constant is the 10, coefficient on x is 5, coefficient on x squared is 2, and coefficient on x cubed is 1. So our quotient's going to be x cubed plus 2x squared plus 5x plus 10, and I'll let you check this one. So example 3 is another way to word the question that's asking you to still do synthetic division, but it wants you to determine whether x minus c is a factor of the polynomial. So this is the same as saying, is x equal -3 a 0? Okay, so remembering that the 0 is what goes in the pocket. Coefficient of x to the 6th is 2. X to the 5th is 0. X to the 4th is -18. X cubed is 0. X squared is 1. X is 0 and -9. So synthetic division, 2, -6, -6. 18 and -18 is 0. -3 times 0 is 0. 0 plus 0 is 0. -3 times 0 is 0. 0 plus 1 is 1. -3 times 1 is -3. Add. And I get 0. So if I get a 0 remainder, go back to your 4 equivalent statements and say, wow, I know a lot of things now. I know that x plus 3 is a factor because the remainder equals 0. Then I also know another factor. So here's the constant, the x squared, x cubed, x to the 4th, x to the 5th. So I know that 2x to the 5th minus 6x to the 4th plus x minus 3 is also a factor. And so I know if I multiply these two back together, I have to get my original function that I started with. So this polynomial that's the quotient is also called the depressed equation. It's after you've factored out x plus 3, it's what you have left. And sometimes that will factor more, it just depends on the problem. So if x plus 3 is a factor of that polynomial, let's just make sure we're clear on what else does that mean we know. So we know that -3 is a 0 of that polynomial. We know that -3, 0 is an x-intercept of its graph. So if we were graphing it, that would be really helpful to know. X plus 3 is a factor because it divided evenly. So then we also knew the other factor with the quotient. And then we also know that f of -3 equals 0. Okay, so the remainder theorem says if f is a polynomial function and you divide that polynomial function by x minus c, then the remainder is f of c. So this could be a much more efficient way to evaluate f of c. If it's a really complicated, long polynomial, I find I am much faster at synthetic division than at plugging the number in. So here's how to use the remainder theorem to find the remainder when you're dividing this polynomial f by x minus 2. So recall that the remainder is the f of the function. So we're going to divide by 2. Well, we're going to put the 0 of 2 in the synthetic division. And keep in mind that we're dividing by x minus 2 when we put a 2 here. Then the x to the fourth term has a coefficient of 4. There's no x cubed. Negative 15, the coefficient on x squared. No x's and a negative 4. So then let's do our synthetic division. And we got a remainder of 0, so that means f of 2 is 0 by the remainder theorem. So whatever remainder you get, that is f of the 0 that you put. Actually, I should say this is a potential 0. And a more typical way I would ask the question is use the remainder theorem to find f of 2 for that polynomial, because I want you to put that all together, that whatever the number is in the pocket, when I find the remainder, it is f of that number. So here's an example. Use the remainder theorem to find f of negative 3 for this given polynomial. So if I want to find f of negative 3, I put negative 3 in the pocket. But keep reminding yourself that this means I'm dividing by x plus 3. Okay, so I have negative 5x fourths, 7x cubes, negative 13x squared, 10x's and negative 4. Drop down the negative 5. 15 and 7 is 22. Negative 66. Negative 79. 237. 247. Then multiply by 3. And get negative 741, so negative 745 is the remainder. So that tells me f of negative 3 is negative 745 using the remainder theorem. So if that's what the instructions say, you must do it this way. You could check by doing f of negative 3 the old way that you know. And you'll get the same result, but I actually think the synthetic division's a lot easier. So let me know if you have any questions.